So my name is Gaetano Borriello. I'm a faculty member in CSE at UW, and this was my sabbatical year here at Google, and actually at the Google Seattle office, but working closely with folks both on the google.com side and the google.org side. Of course, the work I'm going to describe here on Open Data Kit is due to all those people at the bottom. I'm the one who probably had the least to do with getting this done. But you know, just to give you a sense of my background, I come from the ubiquitous computing community, and my emphasis has been on the hardware side of that community, the embedded systems that make for ubiquitous systems. And what I wanted to do on my sabbatical was create a flexible open source data collection tool that we were targeting community health workers, people who go around to deliver healthcare to people in underserved regions. And I wanted to also get involved with Google because this is the kind of thing that only can have impact if you do it at a reasonable scale. And it's hard for a university to get involved in projects of that scale without the kind of support you can get from an organization like Google. So that's why I wanted to be here. And then as a side benefit, I also wanted to learn about Google technologies such as Android and App Engine, bring those back to my activities at the university in ubiquitous computing, where these technologies can make a big impact. So that was what I was after. Let me tell you a little bit about community health workers. They're the people who bring health care to people who can't get to it themselves. And most of these workers are usually hired by governments or NGOs working in various countries. Also, even in the United States, we have a lot of community health workers who serve poor communities, the homeless, and groups such as those. They're really the first line of defense in ongoing healthcare, and they provide regular home visits in the villages where people live. They know their community. They're the eyes and ears for the health system in a lot of these countries to see what's going on. They also provide education for best practices, how to properly install mosquito nets, how to build appropriate latrines, cooking practices, and so on. And the current methods they use for doing a lot of their work is based on paper. These are some examples of the kind of paper forms that these folks deal with. We've literally seen trailers full of these forms sitting waiting for data entry. So there's many, many months before this data actually gets into a usable state. And they also don't do a very good job of using historical data to help them figure out what might be going on, like you saw in the flu trend stuff. So our goal was to basically build a mobile system that would allow them to collect data, get it to a database quickly, and start seeing what's really happening, putting in those buttons for those various diseases, basically. So we wanted to have the CHW have a phone that could help them with the home care, make sure they went through the protocols and checklists in the appropriate order, help them create new outreach programs, help with outbreak detection, and just general improved healthcare surveillance of the population. At the same time, we also wanted to standardize how the data was collected, provide better supervision of their activities. This is a human resource issue with a lot of these groups, as the community health workers tend to be very undertrained, very mobile workers that come and go from different organizations. And so we wanted to do a better job of supervising them and helping them do their questioning appropriately. So what we built was this thing called Open Data Kit, which is a whole suite of tools centered around the Android client and an App Engine backend that collects the data. And I'll tell you a little bit more about that, but basically it's a set of forms that appears on the screen of the phone. The forms are actually quite flexible. They allow all kinds of data types, including GPS coordinates, photographs, video. We also integrate with the barcode application on the Android, so you can read barcodes and do inventory kind of things, patient identification, and so on. all that data goes into an App Engine backend that can then present a Google spreadsheet that lets you look through all that data or visualize it in different ways, put it on maps, and so on. We are currently involved in 2 deployments, one in Uganda and one in Kenya, with 2 different groups. And I'll tell you a little bit more about those in a second. That's our website. All the code that we've generated is open source and is freely available for download. So the two deployments I wanted to mention, the one on the left is an earlier one from about a year ago, sort of the first version of this that we were trying out. And that was done in Tanzania with a childhood illness protocol. So this is sort of how do you triage kids that come screaming into a clinic with their parents, usually their mother, and you have to figure out whether they really need to see the doctor or not. And the reason you want to filter that is because there's only one doctor and there's a lot of screaming kids. And you got to figure out which ones really need the extra help. So there's a WHO protocol, basically a flow chart of what questions to ask and what measurements to take. And that takes you to a conclusion about what to do. The problem is that this is a paper chart. And a lot of the workers that were doing this triage were not following the chart because it looks like you're trying to go through a manual while you have a screaming kid in the office with you. And, you know, parents don't react well to that. It's like, what are you doing? You know, take care of my child. And you're using this paper manual, and then they would get lost in the flow chart and, you know, to go to page 19 if yes, page 27 if no. Then I figure out how did I get here and, you know, have to retrace their steps. So that was a bit of a problem, and they weren't adhering to the protocol. So what we did is basically put a form on a mobile device that had the same exact flow chart. But now the person, this is now the social effect of this, the worker doing this now has this fancy device that they're using, and the parent is all impressed. It's still a paper flowchart. It's not any different. But the one difference is, though, that 2 things. One, actually, is that they can see how they got to where they are. Basically, what we did on the screen is leave the answers from the previous questions so that you can see sort of how you arrived at this next question. It wasn't just, you know, I'm on page 19, how did I get here? And then the second thing is that the data was already entered, and it could go into the clinic's records right away. So you didn't have to do a separate data collection step or a note-taking step associated with that. So the adherence went way up because of this, you know, from something like 60% to 90% in doing that. So we got better conclusions about what to do with the child. The one on the right is one that we're involved with right now, and this is now going to go to 300 community health workers in southwestern Kenya. And it's for an HIV monitoring project where community health workers are going out to known HIV patients who are taking medication, and they're finding out how their compliance is in taking the medication, what side effects they're having, whether they need to get referred back to a clinic for adjustment to that medication or follow-up visits with a physician. And there's an interesting aspect of that to also connect to a database of medical records to help them track trends in the disease and how the drugs are reacting among the population that they're trying to treat. All the work that we've done has been really leveraging open standards. The forms that we use, for example, are a thing called X forms that was designed by the W3C. And this allows us to run the same form on many platforms, not just Android. So in fact, you saw 2 there on the previous slide. One was a PDA device and one was the Android. Using you know, standard client-server APIs allows us to use different servers on the back end and make that flexible, because sometimes, of course, governments have reasons why they don't want their data going into a cloud that they don't know where it is. They like to keep some of their data more local. And the Android platform being open source and leading to many different implementations, you know, you're going to get a G1 after you fill out the survey. But there's Android phones coming from Samsung and many other providers besides HTC that builds the G1. So that'll provide some flexibility. And we've connected to another organization called Datadyne that puts out a data collection tool called EpiSurveyor on really cheap phones. So they don't do pictures, they don't do GPS, they don't do all that fancy stuff. But there are times when you want to have cheaper platforms for many people to use. And so we now can cross our forms and cross our servers. So our data can go to their backend, their data can come to our backend, and we can build up a mixed system very easily. So right now we're involved in expanding our range of deployments. We have an SMS app evaluation that brings up a survey after you use an SMS service for doing things like a local search, for example, related to agriculture, health, and weather questions. We have one with the School of Veterinary Medicine at the University of London. Deforestation monitoring, and this is an interesting project that the Geo team here at Google is involved with. And there was actually a workshop just 2 days ago. I don't have some of the data that came from that, but they had 40 people from around the world who were interested in the deforestation issues. And what they're doing is integrating satellite imagery that's looking down and detecting changes with on-the-ground validation of what those changes might represent. And what we did with that group just 2 days ago was give them all an Android phone and sent them out on the grounds of the campus of the Gordon and Betty Moore Foundation. And they all went out and mapped trees. So they took pictures of trees, answered a set of questions about the condition of the tree and the environment around it. And while they were doing that, that information was flowing right back into their conference room and into a Google map that showed all that data on the screen. So when they got back and reconvened, all their pictures were already on the screen and all indexable via the map. So there was a picture of the campus and a little marker for each of the things that they took a picture of. So that we just got word that the Brazilian delegation that was here to look at that just canceled a contract that they were about to sign to get somebody to build them such a data collection system, and are going to be using ours. So that was a nice thing. Now, if I could only get that money to UW, that's. And then the last thing is a different kind of project altogether related to business search, and this is the problem where you in countries without well-organized yellow pages, and you got to figure out how to tell people about business services that are available. And we're working with a Google group in India that's going to be sending out people to take pictures, interviews, GPS coordinates of businesses so that they can be provided as search results. So you can actually see the shopkeeper on the screen and telling about the kind of services they provide and decide whether you want to use them. So that's a very nice new kind of search capability. I wanted to just give you a sense for the data kit is not just a form system on the phone. That's the top tool, the collect tool. But then there's the back end on the server that we call aggregate. There's a submit tool that does smart transfer of the data using a variety of transport protocols, depending on what's available and what's been historically available for that device. A tool called Manage that lets us remotely manage the phones and decide what forms they should have on them, what databases they should have on them, and transfer those files automatically in the background so that the user doesn't have to worry about keeping up with that. So we can literally have a green light that every phone is up to date, a red light when phones aren't up to, when haven't been contacted, and yellow for transfers in progress. We also have a task management system, so we can hand out tasks. You know, here's what you should go do and the people you should go visit. We're working actively right now at connecting forms to existing databases so we can pull previous medical records and bring them into the form as well. So we can say, you know, take this person's blood pressure, and if it's less than before or more than before, do different things. The forms, by the way, have all kinds of logic available to them and so on, so that we can do different questions there. Set of visualization tools, supervisory functions, day planner for the community health workers so they can figure out where to go. And then an SMS community notification system as well that can transfer information to people in the community. So, you know, in conclusion, you know, I think we kind of set out with a set of goals that we really feel that we're achieving very quickly. And now we're seeing actually a user community building around this open data kit, and lots of people starting to use it just on their own without us holding their hands. And we have a whole bunch of next steps that this platform is now going to provide a springboard for some much more interesting research activities around that. Yeah, question.
I don't abide by the microphone rule. That's really terrible. Any case, I had a question. So have you thought also about connecting devices to the mobile device? So, blood pressure monitors, or there are a lot of open standards that are emerging in that regard.
And in fact, that's the last bullet there, is what we're trying to do is actually use the phone as the centerpiece of building up a set of medical instruments. The otoscopes to look in the ear, smart stethoscopes that can actually help undertrained people take good heartbeat recordings that can be added to the medical record and actually provide a historical background, for example, for a physician to look at later, maybe years later, to be able to see how someone might have changed. The current Android doesn't allow you to connect a new USB device to it. So we have that limitation, but that'll be coming with one of the later releases. So we'll be able to connect other devices to it as well, and other electronic devices. But right now what we're doing is trying to exploit the microphone and camera as much as possible for doing this. And there's quite a bit you can do with those devices alone. Yeah. I'll repeat your question. I can hear you fine.
So I just wouldn't, Alfred, that's important, but I wouldn't underestimate just the ability to prompt someone to enter the value from their, CVS purchased blood glucose or blood pressure measure.
Yeah. Right. No, that's absolutely right. And I think, but there are some interesting applications. For example, the CellScope project at UC Berkeley, which is just adding some extra optics to the camera, basically turning it into a microphone, to a microscope. Microscope, and be able to, what they do right now is just let you see that image on the screen, but you can actually do things like count cells in a blood smear. Now, what would be really interesting is try to do that automatically so that you can do it quickly and you don't have to have somebody well-trained to do that. And you can use an undertrained population that we often have to use in these cases because we just don't have the people with the extensive training that might be required here. I mean, these are literally people who get like 2 days, here's what to go do, get out there and do it. And they're actually prescribing drugs to people. Yeah. Yeah.
This will help.
Microphone is coming.
Thank you. You hinted that you could run the things sort of offline.
Yeah.
And I was kind of wondering, what sort of the limitations of how long can you run it offline? How many patients can you see before you basically run out of memory?
Yeah, so the phone is actually not in use for all that long, so that we don't do things like actually track track the location of the health worker as they move every second of the day. We just take a GPS reading when they're at someone's home.
Right. No, I'm saying that, but
yeah.
I assume that you're storing the data.
So
they're taking sort of data and storing it. I mean,
yeah. And
how long can they be out in the field before they basically run out of memory in their phone and got to come home?
Long time. We're not even close to getting any limits. Even taking lots of pictures and so on. There's an 8 gigabyte SD card in the phone. You can take a lot of pictures in 8 gigabytes.
Have you ever thought about the problem that you've handed a very valuable phone to somebody in country?
That's an interesting point. That's come up in that it's a fancy new phone, right? And in fact, we've done things like, the theft issue has arisen. But when you're sending people out, they're carrying a lot of medications with them. They have a lot of other things that are valuable that are, in terms of cost, are about the same as the phone. So it's not an order of magnitude difference or anything like that. But yeah, it has come up as like, people are looking at my phone a lot. Another thing that always comes up is people say like, you have unsophisticated users, right? And what are they're not going to be able to deal with this complicated phone. And that's turned out to be a total red herring. We've given the phone and actually had eliminated a whole bunch of apps so we didn't confuse people and everything. They were reinstated within seconds because they got to get to their YouTube videos and things like that, right? So, no problem. People figured it out pretty fast. The thing that they don't like is the QWERTY keyboard. A lot of the people we were dealing with were like, well, who was who decided the order of these letters? It's like, can't you just put a phone keypad on this thing and they're at least in alphabetical order? You know, so they really like just the 10 buttons, you know. Yeah.
The appropriate common medications in case you could remotely diagnose something
These
like
people
that.
are already handing out medications.
Oh, they are, okay.
Yeah, and the locking isn't the issue, really.
But then would decrease the chance of mistakes too, right?
Yeah, no, but it's really just figuring out the right thing to do in a lot of cases. And each organization we deal with has a very different model for how to do that. So that's something we've left off a little bit, you know, because it's just too much variation for. We haven't seen a way to make that one particular model that could work for a general, you know, everyone involved.
So.
Okay, I think we'll stop here, right?
Thank you very much. Thank you.